Hello everyone. Welcome to part 4 of my video series on statistical significance testing. So in this video, we are going to talk about Wilcoxon sign rank test. So in the previous video, we talked about Wilcoxon rank sum test. It is basically a variation of that, and it's fundamentally different in a few ways. So we are going to discuss about that in this video. If you don't know about the rank sum test, you can check out the previous video, but I can assure you that this video doesn't really have much dependency on the previous video. So let's dive in. So first of all, let's look at this from the lens of an example. Suppose we measure test scores of 1000 Bangladeshi students before and after the special classes. Basically, the students are giving exams before the special classes and after the special classes. Now, what we are trying to measure is, do the students get significantly more or less marks after they go through those special classes, right? So it's a very simple thing. It's a paired version of testing because we are now looking at each student separately. So for each student, we are looking at whether they are getting more marks or less marks after these special classes, basically. So it's a paired test. So these are the hypotheses. So first one, the null hypothesis is that there is no difference in marks. And then the alternate one is there is significant difference in marks before and after the special classes. So I think this is something every one of us sort of understands now. Okay, so just for this example, we obviously cannot demonstrate 1000 students. So let's just for the sake of this example, let's demonstrate 5 of them. So these are the before marks and these are the after marks for each of the 5 students. So just by eyeballing these numbers, we can see that the numbers are growing, but in one case it is also decreasing. But obviously in statistical testing, we are going to objectively determine whether this is significant or not. So here is the idea. Let's discuss the idea first, and then we are going to see the concrete example. The idea is we are going to take the sign difference for each student. That means what happened after minus what happened before. And then we are going to rank the absolute value of these differences. After ranking, we are going to sum up the positive difference pair ranks. And we are also going to sum up the negative difference pair ranks separately. So these two things will sort of give us how extreme, right? How extreme these sums are. And using this measure of extremism, basically, we are going to get the p-value. I mean, if you haven't really understood what I mean by these things right here, don't worry. I'm going to now show you a concrete example of how this is actually done. So these are the before and after marks after the special classes. So what we are going to calculate here is something called W-stat. So in the previous video, we talked about the U-stat. So here, instead of the U-stat, we are going to talk about the W-stat for this case. So this is the difference. So 55 minus 50 equal to plus 5, 54 minus 55 equal to minus 1, and so on and so forth. Then we are going to take their absolute values. So there is no sign here. Now what we are going to do is we are going to sort these absolute values right like this in ascending order and then assign them ranks. Now, obviously you guys have one question here. Why do we have 3/4 here, right? So you can see that these numbers right here are equal. These differences are equal. And so, I mean, obviously you could assign 3, 4, and 5 right here. But if you take the average of 3, 4, and 5, it is going to be 4. And we are going to assign that average to all of these. That's how this is done. So these are basically your rank right now. These are signed ranks. Okay, so these are absolute ranks and these are signed ranks. So here the difference is positive. So we assign a positive number right here in these two cases. Here the difference is negative. So we assign the negative number in this case and then the positive number. So the first thing is we are going to calculate the ranks and then we are going to assign sign to them based on the sign of the difference. Okay, that is why it is called the signed rank test. Okay, this is called the signed rank test. So what does this sign mean here? This sign means here that plus means here that the difference is positive. That means after you go through that special class, you have like some increase in mark, and those are ranked high. So 4 is higher ranked, right? These are higher ranked. And if you look at the minus sign, it means that the mark has decreased, right? And because this is only 1, that means the rank is actually very, very low for this as well. So what we're going to do is we are going to take the sum of the plus ranks, so 4 plus 4 plus 2 plus 4, and we are going to take the sum of the minus ranks. So there is only one minus rank here, so this is going to be 1. And finally, we are going to take the minimum of these two, which is going to be equal to 1. Now you may ask why we are taking the minimum, because I mean there is no limit to the maximum, right? It depends on the data set that you are working with. But obviously there is a limit to the minimum. It can be like the lowest can be 0. The lowest can be 0 no matter what, right? So if our W value is very close to 0, then it is more extreme. So closer to 0 means more extreme case, right? That means the difference is actually more significant. So this is something I'm just saying to you right now, but let's see that with an example of how to get the p-value using this table that we just saw. So a few things to note here, a few things to observe, because in this dataset we have total 5 sample pairs. That means we are getting 5 differences. That means we are getting 5 ranks, right? Now, each of this rank we can assign either positive or negative, right? Which we already did in the previous slide. So according to the null hypothesis H0, where we are saying that there is no difference, the plus and minus sign are actually randomly assigned to the 5 ranks, right? So it should be randomly assigned according to the H0, not according to the reality, but according to H0. So the question is, how many possible ways can we assign plus or minus sign to the 5 ranks? So if you have done your permutation combination courses, you know that the answer is 2 to the power 5 equal to 32. So there are 32 possible ways of assigning plus or minus sign to these 5 ranks. For example, I'm giving you 3 examples here. So these were our ranks, the absolute value of the ranks, 4, 4, 1, 2, 4. If you remember from the previous slide, you can just like recap to the previous part of the video to make sure that I am actually talking sense here, because these were the ranks that we assigned previously. Now, if we randomly assign ranks, we can assign plus, plus, minus, plus, plus here, which would give us a value of W equal to 1 if we do the math, basically. You can also assign plus, minus, plus, minus, plus randomly, and then we will get a value of W equal to 6. We could also assign plus everywhere. In that case, we would get W equal to 0, which is the most extreme case. And so we can keep on going like this for 32 rows, right? 32 possible values are there. So we can calculate W for all 32 of these cases in this way, just as I showed you right now. So here is the thing. This is not a real table. This is just a conceptual table for you to have an understanding about what's going on. So if you finish calculating this table right here, the 32 rows right here, then what you can do is you can also calculate this. So basically what I'm saying here is there are two cases. There are two cases in this table, in this 32 row table, where W equal to 0. There are two cases in this 32 row table where there is W equal to 1. There are 6 rows in this table where W equal to 4, and so on and so forth. So the question is, what is the probability of W less than or equal to 1? Now, why are we talking about W less than or equal to 1? Because previously, in the previous slide, we saw that W was equal to 1 in our calculation. So we just want to know what is the probability of us getting something as extreme as W equal to 1 or even more extreme. So anything below 1 is actually even more extreme. So what is the probability of getting that, right? If that probability is pretty basically low, if that probability is very, very low, and we're still getting it, that means we can reject the null hypothesis, right? And this is the p-value. This is basically the p-value, right? So if the p-value is low, we can reject the null hypothesis. So in this case, you can see that there are two cases with W equal to 1. So 2 by 32. And there are two cases with W equal to 0. So an additional 2 by 32, which is going to be 0.125. This is not significant. Now, obviously, before when we were looking at the table, we thought that there is a significant difference. There is significant increase of marks. But as I said in the first video, that if you have a low number of samples, then it is very hard to get a low enough p-value to reject the null hypothesis. So this is one of the lessons for this video as well, that you need to have enough samples in your data set to actually do an effective analysis in statistics. Okay, now suppose you have a lot of samples, which is greater than 20 samples. In that case, you would get how many possible ways? 2 to the power 20. That's a lot. we cannot do all those calculations. It is going to be very cumbersome. So in such cases, we are gonna estimate a normal distribution, and it is going to be estimated from the expected mean and variance of the ranks. And the p-value will be obtained using the W, which we got in the previous slide, the mean of the distribution and the variance of the distribution. Now, if you don't know about normal distribution right now, that is completely fine. We are going to talk about that in detail when we cover the z-test. Okay. So thanks very much for watching the video. If you like the video, feel free to subscribe and share. And there is a donation link in the description. You can donate to our channel as well. Thank you very much.